Hello, my name is Nick Shipman. This is Interactive Advanced Concept Presentation 3 called Volcano. All right, so I don't have my cinematographer here with me today, so just gonna be myself. But I've got my vinegar right here. I've got my sodium bicarb right here. I measured out to 10 grams of sodium bicarb. I was going to do a mole, but then as I started measuring, I realized that is a lot, and I'm not trying to explode my house. So I'm gonna take my bicarb, sodium bicarbonate, put it into my water bottle here, hopefully. There we go. I'm gonna do this in my sink. Got my vinegar. Gonna go ahead and we'll put it in here. And maybe add a little more vinegar. I'm kind of missing. Maybe I should have added more sodium bicarbonate. Not really getting much of a volcano effect. Can see some bubbles in there. So, yeah, I think I probably needed to add more sodium bicarbonate. I guess there's a chance this cat, it's not that old, so there's a chance it could have been interacting with the air. Anyway, so vinegar, acetic acid, and sodium bicarbonate. It's CH3COOH plus sodium bicarb, which is NaHCO3. This is an acid-base neutralization reaction. So what do we know about vinegar? We know that it's a weak acid, which means that it's a weak electrolyte. It's a Bronsted acid. I'll bring this a little bit closer because I realize you probably can't see. It's a Bronsted acid, which means that it's going to contribute a hydrogen ion when it's in an aqueous solution. So what do we know about baking soda or sodium bicarbonate? We know it's a weak base, which makes it a weak electrolyte. And we know it's a Bronsted base. That means it's going to contribute a hydroxide ion and accept a hydrogen ion, and those together are going to make our H2O, our water. So what else do we know about weak acids and weak bases is that weak acids and weak bases will not completely dissociate. So that means dissociation means they break completely apart into their constituent ions. So these ones we know will not. Okay. So what we're going to get for our balanced chemical equation, we have our acetic acid CH3COOH plus our sodium bicarbonate NaHCO3. That's going to lead to react to make sodium acetate C2H3NaO2. And it's also going to make water and CO2. Okay, so why does the volcano effect occur? So there's a couple of reasons. So one, the CO2 turning into when it reacts, it's going to turn that into a gas, and the gas is going to create those bubbles. And in a small space like our bottle here, the gas is going to try and escape out the path of least resistance, and so that means it's going to create that volcano effect going up and coming out that path. So there's that pressure, but there's actually two reactions that are happening. So you have your first reaction, which I just explained, which is the acetic acid with the baking soda, but that actually creates carbonic acid and sodium acetate. And then that second reaction is a decomposition reaction, and the carbonic acid decomposes into your water and your H2O. So that is What will happen, sorry, I'm just going to check my notes, make sure I've got everything I wanted to say. Yeah, I think that's all I wanted to say. So that is how acid-base neutralization reactions work with acetic acid and baking soda.